Hi there. Today we're going to talk about risk analysis and analytics with Safran Risk. My name's Ian Nicholson. I am VP Solutions at Emerald Associates. I'm a risk analysis trainer and consultant. I've been working with risk analysis tools for cost and schedule since the late 90s. Um, Normally joining me is Mary Lynn Backstrom, who also does risk on our company, but she's not available this evening. So why conduct risk analysis? Well, the first thing is it helps the project teams and executives understand and manage the risks on their project. It gets the project team discussing the challenges of the project and keeps the project team focused on the right issues. So, on the schedule side, we're talking about the near critical paths that can come back and haunt you on your project. On the cost side, we're talking about minor cost items with a lot of uncertainty that can end up breaking the budget on the project. Now, risk analysis is a requirement of many companies' gate approval processes, but that's not really why we should be doing it. We should be doing it to understand the dependencies between our cost and our schedule and how likely we are to be on time and on budget. I live in Alberta, Canada, and over here we have a group called the Construction Owners Association of Alberta, and they've identified for a number of years that project risk assessment has been shown to significantly reduce project cost and schedule growth. So ask yourself, do you build detailed CPM schedules? Do you develop detailed cost estimates? Well, of course you do. Everybody does. But somehow our projects still aren't being completed on time and on budget. Well, how can this be? Well, we do detailed CPM scheduling, but there's some problems. And the first one is that we enter our data as finite values rather than ranges of uncertainty. So we'll estimate that this work is going to take 3 people 4 days at $100 an hour. The problem with that is that the assumptions change over time. Maybe it's going to take a crew of 4 people, or maybe the cost is now $125 an hour, or maybe it's going to take more than 4 days to do the work. And those assumptions that we make don't always match reality. And sometimes the project itself changes. We have different scope, time, and conditions in which we're doing the project. If we plan to do the work in the middle of summer and we end up actually doing the work in the middle of winter, our productivity estimates can be way off. We do detailed estimating, but the problem is sometimes our estimators are too optimistic or sometimes they're too pessimistic. Um, Open bid processes tend to encourage aggressive estimates. Estimates add their own contingency. Estimates are built on historical experience, which may or may not be valid. And sometimes estimates are scaled from a smaller project and they don't actually scale to match the work that has to be done. Now, all these items are what we call deterministic. So, what's a deterministic value? Well, a deterministic value is a single point value that we use to estimate work. The problem is it doesn't take uncertainty into account. And our uncertainties can build on one another to make our project quite different from what was originally planned. There's uncertainty in everything that we do. I can't tell you exactly how long it's going to take me to drive to work every day, but I can tell you, it's going to take me exactly 18 months to build a project in the middle of nowhere that I've never built before. So, we need to think about what are the uncertainties that may impact our project, and we need to be realistic about how those uncertainties may impact our project. Now, historically, there was no easy way to model cost uncertainties and schedule uncertainties together. And what we really need is a probabilistic cost and schedule risk model together. Um, there's people have done cost models and they've done schedule models, but it's been very difficult to combine them. Again, going back to the Construction Owners Association of Alberta, they say that on average, projects in our part of the world experience a 19% project cost growth and a 17% project schedule growth. So we kind of know that cost and schedule are intrinsically linked. Um, it's pretty difficult for our project to go over time and not also go over budget. Um, but what we really want to understand as a project team is just how tightly correlated are those two values. So what we need is we need to be able to model our schedules and costs more accurately. We need to limit our financial exposure. We need reproducible results, so we have a solid methodology and a solid audit trail. We need to improve the likelihood of project success. We need to have confidence in our estimates and our results. We need buy-in from our team members. We need to increase our team's maturity in conducting risk analysis. And ultimately, we want to store everything in a common database so we can develop a best practice process around our risk management. So Safran Risk is a great solution for that. Now, I mentioned earlier that I worked for many years using PERTmaster, which became Primavera Risk Analysis, and that was a great tool when it came out in 2002. But the last major upgrade of that tool was in 2013, and the last patch was in 2015. So it's been a long time since things have changed in the software, and yet what we consider best practice has changed significantly. So Safran Risk is more up to date and more aligned with industry best practices. Now it still lets us do ranges on estimates. It lets us model risk events. It lets us model logic uncertainty, and most importantly, it lets us do integrated cost and schedule modeling. So this lets us understand the probability of achieving our end dates and costs, understand the key drivers on the project and their effects, understand the trade-offs between cost and time. It allows us to run detailed scenarios and detailed mitigation strategies. So let's dive in and take a look. I'm just going to share my screen. Okay, so this is what Safran looks like. When you come in, it gives you a little welcome page that lets you do a number of different things. The first one is you can open an existing project. You can import a Safran project file. So Safran Risk is built on Safran project. You can also import a Microsoft project or P6 file. So most of my clients use P6 as their scheduling tool, and it's very easy for them to import those P6 schedules into Safran. Now, it also gives me the ability to uh, go to a history of what I've had open before, and I'm going to open this fairly simple project, which is a unmanned air vehicle project. Now, when we open up Safran, it takes us to the schedule module, and it gives us a Gantt chart. As I said, this is built on Safran Project. Safran Project is similar to P6 in terms of its capabilities and size and everything else. And you can do things like you can create layouts and filters and change your grouping and sorting, all those kind of things. If you need to make changes to the schedule, you can do so right in the tool. You don't have to go back to P6 or Microsoft Project. Now, across the top of the screen, the system has a number of tabs. And the idea here is as I work through building my model, I'm going to work left to right. So I'm going to start with my schedule tab. I'm going to look at my schedule warnings. Then I'm going to look at my risks. Then I'm going to map my risks. Then I can build my cost model, my correlations. I can run the analysis. So all these kind of things are available within the tool. Let's start working through. The first thing is we can go to the schedule warnings tab. And what it tells me is that it tells me that I've got some items here that might be a problem for running risk analysis. So it tells me that I've got some long lags in here, and I've got a couple of activities with no predecessors or successors. Now I can configure this. I can tell it what I want to look for, or maybe what I don't want to look for. So I have that capability within the system. And I can jump to any one of these activities to take a look at it just by right clicking on it and saying go to the schedule. So it'll take me to that activity, and I can repair any issues that I have. If I'm okay with these, I can just say, yeah, I understand, I accept all of these. Now, accepting them just turns them off as a warning. It doesn't actually change anything in the model. But if I come back later and I want to look at my model again, I can see I've reviewed these and I've accepted them. I can also make notes about them. So if I've got some constraints or something that I need to live with, I can put a little note in there that I reviewed this and yes, it is necessary. Now, this is very useful if you come back to the model in 6 months and you're trying to remember what you did. You can give yourself little notes about what went on. Moving to the next tab, we have our project risks. Now, for those of you who may have used Primavera Risk Analysis, this combines two different modules of Primavera Risk Analysis into one in Safran. So in Primavera Risk Analysis, we have a module called Risk Factors, and we have a module called the Risk Register. Now, Safran combines those into one place. So the idea is we can build all of our uncertainties and all of our risk events and all of our probabilistic calendars and all of our existence risk all into one module, which we call project risk. So it puts it all in one place so we can very easily see what the risks are on our project. Now, we have different risk types. As I mentioned a minute ago, we have standard risks. Now, a standard risk is a risk that can be between 1% likely and 100% likely. It also has a distribution shape for both schedule and cost. Now, I can choose to only record one of those. So I can record only a cost risk or only a schedule risk, or I can put both in. As I said before, I can define a probability of occurrence. In this case, this ash cloud risk has a 40% chance of occurrence. And I've said that the schedule impact is going to be a relative impact with a triangular distribution of 100, 100, 165%. So it's going to have a shape that looks like this. And my cost distribution is also going to be a relative impact with a triangular distribution of 80, 100, and 150%. So what does that mean? Well, that means that my schedule may go long when that 40% of the time that the risk fires. My costs may go down slightly if that risk fires, but are more likely to go up. Now, I can make my impact relative, or I can make my impact absolute. And if I put in an absolute impact, then I'm going to put in an actual dollar cost when this risk occurs. So an absolute impact, I define exactly what the impact is going to be. A relative impact would be relative to the cost and or duration of the original line item in my model. Now, I can also define a post-mitigated position. So when I actually do my mitigation strategies after I've run the model the first time, I can go back and record what actions I'm going to take to get to the post-mitigated position. I can put in a duration and cost associated with my mitigation strategy. I can then put in a new distribution and a new probability of that after my mitigation strategy is complete. So again, very powerful because it's all in one place. Now I can define a calendar risk. So a calendar risk is what we would call a probabilistic calendar for those who worked with Primavera risk analysis. And the idea is I can define the probability that I won't be able to work on a particular day. So this could be because I'm working offshore and the wind might be too high or the waves might be too high. It might be too hot or too cold in some time of the year for me to be able to work. And I can define all those kind of things. Now, I can also define what we call estimate uncertainty risks. Now, estimate uncertainties are as you would expect, they are uncertainties. So in Primavera risk analysis, we could make what we called risk factors, which were uncertainties, or we could run a what they called a quick risk, which defined our uncertainties. And the idea here is I can just put ranges on. I could say, for example, that I have a low uncertainty, which goes from 95 to 105%, so plus minus 5%. I can define a medium uncertainty, which is minus 10 to plus 15%. And I can define a high estimate uncertainty, which goes from minus 20% to plus 50%. And the idea here with these estimate uncertainty values is I can define any one of them on any particular activity or cost line item. Now, finally, I can have a non-existence risk. And a non-existence risk is what is the probability that an activity will not be required. So in this case, I'm saying there's a 10% chance that I'm not going to have to do this particular activity. And similarly, I can assign this to my cost elements as well. So I can say, maybe I don't need to do the activity and I don't need to spend the money, and there's some percentage chance that I won't need to do that. Now, once I've got all my project risks into my register here, then I can go to the risk mapping tab. And then what I can do is I can assign each of my risks to my activities. Now, I'm just going to turn something off. I'm going to come back to this in just a moment, just to make it a little easier to see. So the first thing is, remember when I looked at the project risks, I had my estimate uncertainty risks. Now those appear as radio buttons. So I can choose one of my estimate uncertainty values. So right now, my design additional guidance systems activity has no estimate uncertainty on it, but maybe I want to put it in as a medium uncertainty. Well, I can click medium and it turns off none and turns on medium. So that's why I say it's a radio button. You can choose one or the other. I can also associate as many of my standard risks or calendar risks as I need to. So I can go in here and I can associate multiple risks to this particular activity. So, for example, I might say, okay, we're designing our guidance system, and maybe part of the concern around that is around our communication with our vendors. So we might want to turn on the communication risk. So I can just click that on, and I can add risks or delete risks as I go. Now, what about the overall impact of all these risks? I've got an uncertainty, and I've got some of these risk events. What is that going to look like? Well, I can go click on the schedule impact tab on the bottom of the screen, and the system will do a little Monte Carlo analysis and show me what, with all of these risks associated with it. So I've got a design risk, I've got internal communication risk, I've got medium uncertainty, and I've got external communication risks, and all of those are mapped individually. Overall, here's what my distribution shape will look like on this activity. Now, this is really useful because if you put on a risk that's way out of range for your activity. So, for example, maybe I have a 1 week activity and I have a risk that has an absolute impact of 6 months. Well, it's going to look pretty strange when I actually look at this distribution shape. So I can get a quick kind of preview and figure out if I'm going to have a problem before I go any further. And if I were to add another risk, for example, I don't know, let's pick procurement delays. If I add one more, it immediately redraws that shape to let me know what it's going to look like with this new risk associated. So again, very very easy and very quick way of making sure that you're putting appropriate uncertainties and risks on each activity. Now, the next question I often get from people was, well, I've been working with Primavera risk analysis, and I like to sit with the project team, and on those things that are critical or near critical, I like to be able to put on a distribution shape specifically on that activity. Can I do that here? And the answer is yes, absolutely. What I can do is I can turn that on, turn that ability on in the options, and then I can actually go in and I can put a distribution shape directly on that activity. So this is not something you'd probably do on all of your activities, but if you want to sit with the project team and say, okay, let's look at the critical and near critical activities and figure out what our base uncertainty is going to look like, I can do that directly here. Now, if I do that, I probably don't want to also include an estimate uncertainty, but I would want to go in and put in my risk events. So in this case, I've put this distribution in. I can see what it looks like. Here's my duration uncertainty. Here's my communication risk and my merger and acquisition risk. And again, here's what the overall um, impact looks like on my activity. Now, I'm going to come back to the cost module in a few minutes. Um, I'm going to move on and I'm going to move to the correlations section. Now, the idea here with the correlations section, let me just turn off some of the noise here just to make it a little cleaner, is that I can take my risks and I can correlate them together so that if I have a risk for, say, a poor soils report, um, that risk may be correlated to my productivity of my piling crew. So if there's errors in the soils report, it's going to cause an impact to my piling crew, and I can correlate those risks together. Now I can correlate the probability of occurrence, and I can also correlate the impact, both from a schedule and cost perspective. So the idea here is I can do this in a grid pattern, which makes it very easy to build my correlation matrix. I don't have to go and link my individual activities or cost items together. I can say the probability of these risks occurring is correlated, which makes it actually very easy to work with correlation. And I'm assuming everyone knows what correlation is, but maybe I should step back and say correlation is just the ability to say if one thing happens, another thing will or will not happen. Um, and when you're dealing with large schedules, you often have to deal with what they call the central limit theorem issue, in which long activity or which activities that are very similar in duration cancel each other out when you run the model. So one goes long, the next one goes short, and they effectively cancel each other out. So correlation is very useful as well to manage the central limit theorem. Okay, let's move to the next tab, which is the Analyze tab. This is kind of where all the action happens. So the first thing is I can very easily turn risks on or off just by clearing the check boxes. All right, so if I want to run some analysis with one of my risks not turned on, I can just go and turn it off very quickly. Then I can turn it back on and run another scenario. I can also choose to run my model with a particular risk in a pre-mitigated position or a post-mitigated position. So if I've worked out my mitigation strategies, then what I can do is I can say, okay, well, let's run a few of these risks in our post-mitigated position. And that allows me to do a lot of what if analysis very quickly. Again, going back to Primavera risk analysis, we could only run everything pre-mitigated or everything post-mitigated. We couldn't do that mix and match, which is very powerful when we actually want to build our model. Now, we can tell the system how many iterations we want to run of our analysis. Um, we can run Latin hypercube or Monte Carlo analysis. We can include or exclude correlations. We can tell the system to do resource leveling after each iteration. And we have the ability to step through the analysis. I'm going to turn that one on. Now, just before we go any further, we also have the ability to define focus activities and focus costs. So what would we use as a focus activity? Well, maybe when we have a big schedule that comes from our construction group, for example, and their schedule has all kinds of detail getting down to the point where we actually turn this new facility over to the owner. And then maybe they've got a bunch of activities afterwards about cleaning up the site and demobilizing and all those kind of things, contract closeout and hold back releases and all that kind of stuff. I don't really care about all that when I'm doing risk analysis. What I really care about is that intermediate milestone of when am I going to turn this thing over to the owner? So what I can do is I can go in here and I can choose those intermediate milestones that I really care about. And maybe I really care about things like, I really care about when the fuel system's connected and I care about when my design is complete. So I can choose those intermediate milestones as what we call focus activities so I can very easily work with them. So now I'm going to click on run the analysis and it takes me to the Gantt chart. And now what I can do is I can just make sure that things are moving the way I expect. Right? So I'm just going to click through a few times. I can move my time scale a little bit over. And I just want to make sure that things are moving the way I expect. And if I have some existence risk or if I have some probabilistic branching that I've built into my model, I want to make sure that those things are firing as well. So I'm just going to step through and just want to make sure that everything's working the way I expect. And when I've confirmed that everything works properly and nothing's stuck and nothing's not moving because of some constraint or something, then I can hit complete. And the system comes up with the overall distribution for this project. And what it tells me here is that my deterministic duration or my deterministic end date, which was October the 20th, is only about a 1% chance of happening. Now, where does that come from? Well, what's that saying is in the 1,000 iterations that we ran on our schedule, we finished on or before that date only 1% of the time. So that would mean 10 iterations of the schedule, we achieved that end date. If we want a little more confidence, we could go up to say a P70 or P80 value. So our P70 value means that 70% of the simulations finished on or before this particular date, which would be April the 24th. So basically what we're saying is we're looking like we need about 6 months of contingency on this project to get ourselves up to a 70% confidence level. Now, that's very useful, um, but what's actually driving me out there? Well, the next tab is called drivers. And the drivers gives us our tornado charts, and the tornado charts tell us what are the risks that are having the biggest impact on our schedule, and also what are the activities that are having the biggest impact on our schedule. So this is very useful. If I want to take a look at this and say, okay, what's the risk having the biggest impact? It's the ash cloud. Okay, well, what can I do about that? There's a 40% chance that we're going to have an ash cloud when we do our testing. Maybe we should do our testing somewhere else. So I could actually go and say, let's find somewhere where there's no volcanoes to do our testing, and we won't have to worry about an ash cloud disrupting our testing. So those are the kind of decisions I can make. My communication is next, my procurement is after that. And the idea is I start at the top of the tornado and I work my way down. But the project team often will say, okay, you said ash cloud is at the top and the correlation is 0.52. What does that mean to us? It doesn't really mean anything. 0.52 isn't a number that a project team can work with. What they want to know is how many days will I save on my schedule if I can get rid of this ash cloud risk? Well, in Primavera risk analysis, we could do that by manually turning off each risk, rerunning the model, turn off the next risk, rerun the model, turn off the next risk, rerun the model. In Safran, there's a much easier way to do that. And that is we can go to the sensitivity analysis tab. And what we can do there, and I just want to flip this to single pass. So what we can do there is we can say, okay, let's look at the impact either on the overall project or on one of our focus activities. So remember we said, we might really care about that intermediate milestone, like turn the plant over to the owner. So we could work that on the what's the impact getting to that intermediate milestone. In this case, though, I'm going to look at the overall project. I look at the confidence level I'm interested in, so at P70, and I can say calculate the impacts. And what the system's going to do is it's going to turn off each risk, rerun the model, turn off the next one, rerun the model, turn off the next one, rerun the model. So what it tells me is that at P70, these are the items that are having the biggest impact. Now you notice that ash cloud dropped down a little bit there. And the reason for that is that we're now looking at it specifically at a particular confidence level. So by the time we get to P70, some of these other things have actually become a larger impact than our ash cloud. So we can say to our project team, okay, if you can get rid of the procurement delays, you can save 35 days. If you can get rid of poor flying conditions, you can save 28 days. And that ash cloud one we looked at, if you get rid of that, you can save 17 days. So this is what we call analysis by exclusion. It's turning the risks off and then turning them back on again. Now we can look at it as a tornado plot, or we can look at it from the perspective of an S curve. Now that's kind of a mess. Let me just start by turning them all off and I'll turn them back on. So I'll start with my none. So my none line means all risks on. Now if I go and then turn off the next item, procurement delays, here's what my curve looks like with that one turned off. So you can see at my P70 confidence level, there's the days I'm saving. So that was my 35 days. And you can see down for different confidence levels how much time we're saving. And I could turn on the next one, my poor flying conditions. That's what that one looks like. So again, it allows me to look and understand how much of an impact each of these is having on my overall schedule. I can even go one step further and I can say, okay, I'm really interested in these top ones. And what I'm going to do is I'm going to go to the options and I'm going to say, instead of doing a single pass, do multiple passes. So what multiple passes will do is it will turn off the first risk, then evaluate what the next biggest impact is, then turn off that one, then evaluate what the next biggest impact. So we can see the cumulative effect of getting rid of these risks. So in this case, I'm going to just turn this off. Actually, let me just check something real quick here. Just want to make sure that we are going off our, oh, yeah, I want to go off schedule, not cost. I'll come back to cost in a few minutes. So then what I can do is I can say, okay, let's calculate the impacts. So there's my all risks on. There's the saving I got by turning off my procurement delays. There's the incremental saving that I get from my testing overrun. There's the incremental saving that I get from my communication risk. So you can see, hey, as I turn each of these off, how much am I saving? And you can see that I'm saving quite a bit on each one, but at some point it becomes narrower and narrower. And I only told it to do the top 5, but you can see exactly how much time you could save by getting rid of each of these risks in turn. Now, uh, we've talked about our um, our schedule. Now let's go back and talk about the cost side. Now I mentioned earlier that people have struggled for many years to do integrated cost and schedule analysis. Now the reality is, if I'm on time but over budget, my project is not going to be considered a success. Similarly, if I'm on budget but late, no one's going to call my project a success. What I want is I want a confidence that I'm going to be on time and on budget. So the question is, what do I need to have for my contingency to be able to do that? Now, in the past, what people had to do was they had to build a cost-loaded schedule, which is a lot of work and very hard to maintain, or they had to take the results of the schedule and feed those into the cost module, their cost risk analysis, which is possible, but it's been shown through a number of studies that that actually pure does not effectively model the impact of schedule on cost. It tends to downplay the impact. So what I really want to do is I really want to have a separate cost model that I can link to my schedule as appropriate. And that's what Safran has done. So let's go to the cost section. So here's my cost worksheet. So I've got this breakdown of all my costs. Now, I'm just going to turn off a couple columns here to make it a little easier to see. So in my cost model, I can have a base cost. Then what I can do is then I can have a distribution of those costs to come up with what my total overall cost is going to look like. So in this case, I've said that I'm going to have a certain number of elements in my model. So I've said here I've got this cost breakdown. Here's what my cost breakdown looks like. And then I can associate risks with this particular model. So I can go in and say, okay, in this case, we can add a couple more risks to these items. So maybe we'll add in a couple of risks here. And we've got only design risk. We'll add a couple more risks. So any of my risks that in the risk mapping section that have a cost associated with them. So remember we had a section for schedule risk and a schedule for cost risk. Any of my cost risk items are available to be assigned here. So if I take this item that I've gone and put my risks on, again, what I can do is I can look at my cost impact. So just like I looked at in the schedule section, here's my basic cost. Here's the impacts that I have, and I can see my overall result. And that one's not showing up properly for some reason. So we'll pick a different one. It doesn't want to display. Okay, that's fine. But the idea here is that I can see again what my impacts are going to look like. Now I can also take this and I can take any of my line items, and if I turn on the schedule connection part, I can link these line items to activities in the schedule. So in this case, I've got my fabrication resources, and I've got $280,000 for that. And what I can do is I can associate that with an activity in the schedule. Now, I may put anywhere from 1 to 100% of the cost and link it to the schedule. So some items are entirely not schedule related. So in that case, I won't link those ones to a schedule, but some of them are going to be strongly linked. So in this case, I've got this line item here, and it is 100% linked to fabricate the lens frame. So what that means is it's going to take that cost, which was $280,000. It says, okay, you've linked it 100% to the 60-day activity. So there's a day rate cost of $4,600. And as the duration of that activity changes, it's going to change the overall cost of that line item. So the items that are cost or the cost items that are schedule related can be linked, and the items that are not do not have to be linked. So I've got this ability to go in and link them however I see fit. Now, I can also go in and I can put formulas in here. So for example, maybe under project management, I want to put in a formula that says that I have a cost for my project manager. So in this case, I'm saying that my project manager is going to cost me probably $50 an hour. And I can build a formula around how that's going to take place. So I can build uncertainty on the items that make up that overall line item. So I can say, okay, I've got uncertainty around the rate that I'm going to pay for my project manager. I've got uncertainty around how much time I need my project manager, and I can build up those formulas. Similarly, you can do it based on quantity takeoffs. You could say, I expect I'm going to need so many tons of rebar at this much per ton. Therefore, here's what my line item looks like, but maybe there's uncertainty around the cost of that rebar, or maybe there's a transportation cost associated with the rebar that I'm not really sure about. So the idea here is I can build all of these up in my cost model. And then what I can do is, again, I can say I want to link it to the schedule, or maybe I don't want to link it to the schedule. Now I can also link to multiple schedule items. So in this case, what I did was I said, okay, 50% of this item goes to this activity, 10% goes to this other activity, and the remaining 40% will be not schedule related. Okay, so this is very powerful because I can determine which of my items I want to link and which ones I don't want to link. Now, again, when I do my analysis, I can go do the step through, but when this time, instead of looking at the Gantt chart and how that moves, I can look at my cost and I can see how that's going to move. So as I step through, I can see how my costs are changing. And if I scroll all the way up to the top, I can see my overall cost. And as I step through, I can see how that's going to look. So I can make sure again that all my risks are firing. When a risk fires, it's going to light up. When it doesn't fire, it's going to gray out. So as I step through, you can see the colors change as my risks fire or don't fire. And then I can see my overall impact. And at the same time, I can see the duration of each of these activities as I step through. So you can see the durations of the activities are constantly changing as well. So there's a lot of moving parts here. I've got the formula that I use to build up the cost. I've got the base uncertainties. I've got the risks. Then I've got the schedule links. All those things built into my costing module. Again, when I'm happy that everything's moving the way I want, I can hit complete. And now, it takes me to the distribution graph, which is the same one I looked at before, but now I'm going to look at that on a cost basis. So here's what my cost distribution looks like. Now, my deterministic cost of $8.3 million is about 9% likely. So my schedule was around 1% likely. My costs are a bit better, around 9% likely. But to get up to a P70 value, I still need to add about $600,000 of contingency to my budget. Now, just like before, I can go in and I've got my breakdown on the side. So if I'm interested in a particular line item, I can, for example, I want to see what my overall labor cost distribution looks like, and there it is. So I can see that I need about $200,000 of contingency on my labor. And again, I've got my focus costs. So just like my focus activities, I can look at focus costs as well. So if there's particular elements that I care about, I can very easily monitor those through my focus costs. So we have drivers on a cost basis. So again, I'm going to flip this to my cost view, and it tells me, okay, here's the things that were having the biggest impact on my overall um, cost. Let me move this out of the way. And I can look at that from a risk perspective. So these are the risks that are having the biggest impact on cost. I can look at it on the basis of which of my cost items are having the biggest impact. I can also look and say which of the activities that I've linked to are having the biggest impact on my costs. Or I can look at everything all in one and say, okay, well, show me everything that's having an impact on my cost. So again, I've got this tornado that says, okay, here's the things you need to focus on. And just like I could do with my schedule, I can do a sensitivity analysis calculation based on cost. So if I go to the cost tab, let's go back and look at it again from a single pass perspective. I can say, okay, I want to look at my overall project cost. I want to look at it on a P70 value again. Let's calculate the impacts. So there's my base cost. And then it says, okay, here's all the money that you can save. Let's sort that by my impact. Let's go the other way. So says if I can solve my transportation issue here, I can save myself $97,000. and one of these is my um, quantity and one is my base estimate. So again, in my transportation cost, I had put in there an uncertainty around how many shipments I needed to have go to site, and also um, there was some uncertainty around the cost of each of those shipments. So you can see here, here's the impact of each of those. So again, I can tell the project team at a P70 value how much money they could save. Now, again, I could look at this on an S curve basis, or I could look at it on a tornado basis and say, okay, if I can get rid of my transportation quantity problem, I could save $100,000. If I can get rid of uh, the cost of transportation, I could save another 80,000. My testing overrun, I could save $70,000. So again, I can look at all of those things um, and tell the project team exactly where I can save some money. So if I've done all of that, um, and I've gone to all the trouble to actually map my schedule and my costs together, one of the things that I really want to be able to do is I want to understand the dependencies between cost and schedule. And this is where it all comes together beautifully, is that I can look at my scatter plot, and the scatter plot tells me, here's how each of my iterations of the schedule is represented by a dot. And I shouldn't say the schedule and cost combination is represented by a dot. Now, if you look at this quadrant here, you can see that in the lower left quadrant, these are the number of times, the number of hits that I had where I was on time and on budget for my deterministic model. And it wasn't very many dots. You can see here there's 1, 2, 3, 4, 5, maybe 6 dots out of 1,000 iterations. And that's not surprising because I had a 9% chance of being on cost and a 1% chance of being on time. So the chances of both is pretty slim. So what do I need to be able to get the confidence up to, say, a 70% value? Well, what I need to do is I need to look here at the way my banding is, and I only defined one highlighter at P70. I could have defined more and I'd see more breaks in here. But in this case, I'm only concerned with P70, and I want to know, where do I need to be to get to a joint confidence level of 70%? Well, that would be right here at the interface between my green and my red dots. So if I look at this dot here, that's 70%, and um, I'm finishing in May, and that would be May the 9th, and at a cost of around $9.1 million. Okay. So if I were to go and say, okay, let's look at May the 9th at $9.1 million. So we're going to actually put in that target date. So May the 9th we said at $9.1 million. That puts our highlighter there, and see we're sitting at around 70%. We're just 69%. So all of these hits, if that was where we put our cost and schedule contingency, if we said, okay, we need a budget of $9.1 million and we need our finished target date to be May the 9th, that gives us a joint confidence level of about 69%. So close enough to 70%. But what's interesting about this is you can see this interface actually has multiple points on it. It's not a single point. So I could have chosen this dot down here, which was June the 5th, at a budget of $9.0 million. So in this case, what I've done is I've said, if I don't want to spend quite so much money and I could live with another month of schedule, I could make that trade-off and I could get this point here. Now, if cost is even more important, I could go down here and say, okay, well, that's going to take me out another 6 weeks, but I could save another $100,000. And what you see if you follow that line is you get a point where it becomes vertical, which basically means it doesn't matter how much more money you're going to spend, you're not going to save any more time in the simulations. And down here, it becomes horizontal, which basically means you're not going to save, no matter how much time you give up, you're not going to save any more money. But between those 2 points is this curve. And the beauty of this is I can choose where I want to be on that particular curve. So I could say, okay, you know, cost is more important to me than schedule. So I could choose a point down here and give up some of my schedule to save some money. Or alternately, I could say schedule is more important than cost, and I could look at spending a bit more money to save some schedule. So the project team has the ability to work within the area where it goes vertical and the area it goes horizontal, and can decide as a project team where they want to be in order to get that 70% confidence level. And this is something that a lot of people are interested in because as a project team, you know, we might be willing to trade off some money for some time. You know, if we're building a UAV, an unmanned air vehicle, getting to market's really important because if we don't, someone else is going to get grab the market out from under us. So in this case, you know, we might say, you know what, we're willing to spend a bit of money to save a bit of time. Okay. So the other thing that you can do within here is once you've actually mapped your cost and schedule together, you can develop a probabilistic cash flow. So you can look on here and say, okay, how am I going to spend the money on my project? And maybe I'll just turn off a few of these to make it a little easier to see. But if you have a project that's running over many years, what you might want to do is you might want to look at it and say, okay, here's what my deterministic look curve looks like. And let me turn on the cumulative curves as well. So here's what my deterministic curve looks like. Here's how I think I'm going to spend my money. Here's what my P70 curve looks like. Now this is really useful. I have a number of clients who have projects that are going on for many years. In one case, I actually have a client who has a project that is over 100 years long. It's a cleanup project. And it's very important to them. They get a certain amount of budget every year and they need to understand how they're going to spend that budget. And if they don't spend it, they lose it. So it's very important to them to understand what's the probability we're going to spend our budget without over or underspending our budget. And if it looks like we're going to underspend, what are we going to do to accelerate some of the work? And if it looks like we're going to overspend, what work is going to get delayed to make sure that we make the best use of the money that we have? So again, you can do this probabilistic cash flow because our cost and schedule models are linked. So again, we can see where we're going to spend the money. Okay, so I'm just going to go back to my slides for a moment. And by the way, if you have any questions that you would like to ask, please feel free to put them in the questions section and I'd be happy to answer them. Um, Now, I've shown you some of the features of Safran Risk. I'm very enthusiastic about this tool. I've been working in risk for a number of years, more than I care to count. And this tool is very exciting in the way that it manages this integrated cost and schedule model. And it's been picked up by clients all over the world. And here's a few examples here in different parts of the world that are using this tool. Um, And my company, we implement this tool for people. We also do training and consulting on the tool. So if people need help, we can certainly provide it. If you are a PRA user and you want looking to upgrade your tool, we can help make that happen. Um, if you're new to risk management and you're just looking to start off, we can help you get rolling. Okay, if there are any questions, please feel free to ask them. Um, and I'll put my contact information here as well. So if you don't have any questions right now, but you'd like to get hold of me to ask some more questions, please feel free to do so. My contact information is here on the screen. Um, and Donna, who is in charge of our office, located in the Philippines, is also available to answer any questions that anyone may have in that part of the world, since timing can be a little bit problematic. Her contact number is there as well. And as I said, please feel free to reach out to us if you have any questions that we can answer. Okay, so it looks like there's no questions. If you do think of questions, again, my contact information is here. Thanks for joining us. It's always a pleasure to talk about Safran and the exciting world of project risk management. Thanks again for joining us.